Hi everyone, and welcome back to another episode of Bluverse. Detailed stratigraphic and structural modeling is a quite time-consuming and arduous task. However, geoscientists are now leveraging deep learning to accelerate and add another level of detail to their interpretations. And so today I'm joined by our global technical advisor, as well as an adjunct professor at the University of Houston, Dr. Anna Krueger. So Anna, welcome on the show. Can you tell us a little bit about yourself as well as your experiences?
Thank you for having me here, Julian. The Brazilian pre-salt combines so many things I love about geology. As a little girl, I loved fossils. I was very passionate about fossils. I love carbonates, I love structural geology, and most of my research is on tectonostratigraphy.
And so those three things are particularly important in the Santos Basin for fields such as Gato de Mato and the Tupi field, especially since Tupi is the largest discovery of the 21st century. And what's particularly unique about the Santos Basin, it's very unusual salt character. It's a multi-mineralogy, multi-layered evaporite sequence. And so Anna, how did this form and what are the implications for that?
As the Gondwana rifted, ocean waters invaded the basin and formed hypersaline environments with the full evaporation of the ocean waters. Complex salts are salts with high composition of potassium and magnesium, and they do form interlayered with the most common kitchen salt that we are all used to, the sodium chloride. And multiple mineralogies have different acoustic impedances, and different acoustic impedances have created these multi-layers of evaporites that we see in the seismic. We don't see in other places.
I see. And so how can we leverage things such as interactive deep learning to better characterize this complex salt interval?
We use the interactive deep learning approach where we mapped the whole sequence of evaporites as a whole, and we use the inference to help us to create new labels. And by working in real time and interactively with the machine, labeling and training, we were able to get better results.
And so here we see the results for a near 2,000 square kilometer survey, and this was labeling less than 1% of the data. And what's really important is that these results were achieved in less than a day. And so Anna, characterizing this very complex interval at such a high level of detail, what does this mean to someone like you that spent a lot of time in the exploration and production side of the business?
It is critical both for geoscientists and for drillers. Drilling through salt is very complex and is very expensive. The most expensive wells in the world drill through very large layers of salt. It's extremely challenging and expensive. Geoscientists like me can use deep learning to get more precise results in our depth imaging models.
And so now if you have a better image, right, then you can map your reservoirs better, which we'll be discussing in the next episode. We'll also be highlighting how we can sort of map those various faults and, more importantly, use interactive deep learning to characterize the poorly illuminated reservoir. So thank you again for stopping by, Anna, and giving us a bit of a flavor of the Santos Basin. We'll be discussing more, and be sure to like, comment, and subscribe for more satisfying bites coming your way.